Hi guys, this is Miss Mariana, and in this video we're going to work with logarithmic equations. We're going to solve two exercises where we will apply the properties that we need to be able to get the equation, solve it, and then make sure that the values that we get are valid in the domain of the expression we're given. So let's start. So here we have logarithm of 6x minus 6 minus logarithm of x that equals logarithm of x plus 1. See that all these are common logarithms where the base is 10. Remember that when the base of the logarithm is 10, we don't write it down, okay? So now that we just read the exercise, the first step that we have to do before doing anything is to find the domain of the expression we're given. So let's do that. First step, domain. So we have 6x minus 6. Remember that for logarithms, the argument always has to be greater than 0, strictly greater than 0, because the logarithm of 0 does not exist. So I'm going to take all the arguments of the logarithms we're given in this expression to calculate and determine the domain that this will result in. So let's isolate x from each expression. So 6 goes to the other side doing the opposite operation. And then the 6 is going to do the opposite operation, which is dividing. So 6 divided by 6 is 1. Then this one, the second one, remains the same. And the last one is clearly x greater than -1. So the result is going to be the intersection of all these inequations. So we're going to write everything down on the number line. So see that the domain of this expression is going to be the interval in which all the inequations intersect, and that is from 1 on, okay? So the domain for this equation will be x greater than 1. And we have to take this into account when we get our final results, and we have to make sure that the final result we get belongs in this interval, okay? Remember that if we want to write down this as an interval, we can do it like this: x belongs in this interval, okay? Remember that as we're working with x is strictly greater than 0, strictly greater, then we don't include the frontier, and the infinite is always open. With this done, now we're going to apply properties to the expression given to be able to get a logarithm on each side of the equation. So let's go with that. So let's begin. Here we have the subtraction of two logarithms. That means that we can convert this into the logarithm of a division, okay? So remember that we have the logarithm of this argument minus the logarithm of this one. So when we apply the property, remember that we're going to get the logarithm of a division. A division of what? The arguments that we have in the logarithms that are subtracting, okay? So first, we're going to write the one that is written first, and in the quotient and in the denominator, we're going to write down the orange one, which is the one that has the negative before, okay? So let's write that down. And we're going to write the other logarithm. So now we have achieved one of the goals, which is to get one logarithm on each side of the equation. to what avail? To set the arguments equal. What does that mean? That we are going to take this argument right here and this one right here, and we're going to equal them. Why? Because as this is an equation, the left side has to be equal to the right side. So if we have common logarithms on each side, then the arguments have to be equal as well. So we write them down. And now we have the equation that we need to solve. And this is going to be a step 3. Now we solve it. This is the expression. Now we're going to solve it here on step 4, where we're going to have 6x minus 6, and this x will go to the other side, multiplying. So x multiplies everything that is on the right side, and here we're going to apply distributive property. As we do so, we get x power 2, or x squared, plus x. We group like terms, leaving x squared positive because it's convenient. Then we get x, this guy that goes to the other side with the opposite sign, would be x minus 6x, it's minus 5x. And this 6 will go to the other side, adding, and we get this. Okay? And this is the equation that we have to solve, that we have deduced from the logarithmic expression. Don't forget that, okay? So here we have a quadratic equation that we can always solve using the typical formula we use to solve these types of equations, or we can use a method that I call the fast track. How do we apply it? Let's go for this. The first condition that we need to have to be able to apply this method is that the coefficient of x squared has to be 1. Then, once we have this condition set, now we have to think of two numbers that added result in the coefficient of the middle term, and that multiplied result in the independent term. So let's think of two numbers that comply with these two conditions. First, we're going to write our two factors right here, where we write our x's. We get two factors because we're working with a second degree equation. So let's think of these two numbers that added, m plus n, has to be -5, and m times n has to be 6. It has to be two numbers that simultaneously comply with these two conditions. So generally, it is easier to start by the multiplication because it's a little bit more intuitive. So I am going to do that. So I'm going to think of two numbers that multiply, result in 6. That's gonna be, for example, -2 times -3. Negative times negative, positive, and 2 times 3 is 6. First condition complied. And now these two numbers, we're going to add them to see if they comply with this condition as well. So we have -2 plus -3. That means -2 minus 3, which is -5. They comply. Once we have found these numbers, we put them exactly as we found them in the factors. That is -2 and -3. Now that we have these factors, we have to equal them to 0 to be able to isolate the x from each factor. X equals 2, x sub 1 equals 2, and x sub 2 equals 3. Now that we have our values from the quadratic equation, we have to see if they are valid for the logarithmic one. Let's find out. Considering the domain of the equation, both are valid because the domain of the equation is x that belongs in the interval from 1 till infinite. That means that 2 and 3 are in that interval, therefore both results are valid for the logarithmic equation. And this would be everything for this exercise. So let's go for the second one. First step, the domain. Let's go for it. So we have 2x minus 2 that has to be strictly greater than 0, x that has to be greater than 0, and x minus 2 that has to be greater than 0. I am going to solve all these inequalities, and I am going to place the results on the number line. Now here we see all the inequalities solved and placed on the number line. So as you can see, the first inequality, the green one that was calculated, resulted in x greater than 1, that is placed here with green. Then the second one is already solved, is x greater than 0, which is the pink one that we see right here. And then the third equation resulted in x greater than 2, which is the orange one right here. So the result is going to be where all the intervals overlap, where they intersect, okay? And this is when we see the three colors together, which is from 2 on. We write it down. So here we have the domain of this expression written as an interval or as an inequality, okay? And it is read as x belongs to the interval from 2 until infinite, or x greater than 2. So let's go into the next step, in which we're going to apply properties to be able to get one logarithm on each side of the equation. So let's begin. So see here, guys, that we have this coefficient right here. So if this is the coefficient of a logarithm, applying the property of the exponent, this coefficient will become the exponent of the argument. So I am going to apply that now. We have the logarithm of 2x minus 2 squared minus logarithm of x that equals logarithm of x minus 2. So guys, see here that the 2 that we have here is now here, okay? Let's continue. The next property is the property of the subtraction of logarithms that will become the logarithm of a quotient of a division, okay? Remember, first we write down the argument of the logarithm that has a positive sign, and then we write down the argument of the logarithm that has the negative before. What does that mean? We have logarithm of 2x minus 2 squared divided by x, where this is the argument of the logarithm that has negative before, and this is the argument of the logarithm that has the positive before, okay? And now we have that this equals logarithm of x minus 2. So guys, seeing this, we have one logarithm on each side of the equation. So we have reached step 3. Now, in step 4, we're going to set the arguments equal by taking the argument of the logarithm on the left side and the logarithm on the right side. And as we have the expression written, we're going to solve the equation. We're going to send this x multiplying to the other side. And remember that it will multiply everything that is on the right side. So we have 2x minus 2 squared equals x times x minus 2. So on the right side, we have to apply the distributive property. And on the right side, we have to apply a special product. This special product is developed as follows. First position squared negative the double of the multiplication of the first and second position, that is 2 times 2x times 2 plus the second position square. And this is equal to x power 2 minus 2x as we do the distributive property. Here we have 4x power 2. 2 times 2 times 2 is 8, x plus 4. And this equals x power 2 minus 2x. Now we have to group like terms, and we get this quadratic equation that we're going to solve with the formula, where a is 3, b is negative 6, and c is 4. So the recommendation that I always give is that before applying the formula, it is necessary or convenient to solve the discriminant. If we solve this, we're going to get negative 12. That means, guys, that this equation doesn't have a solution in the real numbers. Therefore, this logarithmic equation has no solution. So this is everything for this video. See that I put 2 very different exercises to be able to practice the main concepts and things that you might find when you study. So it's important to analyze every type of exercise to be able to understand the kind of solution we're getting and why it can be valid or not. Stay tuned for more videos and keep the good work. See you in the next one.